Hello and welcome to the first video of the quarter. This is chapter 9 and it begins with sequences in sections 9.1 and 9.2. And in this intro video, I just want to define what a sequence is and look at a few quick examples. All right, so as you can see here, a sequence is an index list of numbers. And so I have here just a generic sequence where we're going to refer to the numbers in the sequence as the terms of the sequence. Okay, so A1 is the first term, A2 is the second term, so on and so forth. Okay, you have the generic A sub n is the nth term, and this dot 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 that follows here, just indicating that there's an infinite number of terms in the sequence. Okay, so it's just some list of numbers, right? So let's look at a couple examples to illustrate. So for our first example, we have 1, 3, 5, 7, which presumably continues as 9, 11, 13, so on and so forth, right? It's just the positive odd integers. All right, so here, a sub 1, the first term is just 1. A sub 2, the second term is 3. A sub 3 is 5. A sub 4 is 7, so on and so forth. Okay, now for the second example, we're given an explicit formula to generate the terms of the sequence. So here we have n divided by n plus 1. Now this little subscript here, n equals 1, is just telling us we're going to generate the first term of the sequence by plugging 1 into this formula. And then we'll plug in n is 2, 3, 4, so on and so forth. Now this superscript little infinity symbol here is just telling us that this pattern is just going to continue indefinitely. So there's going to be an infinite number of terms in our sequence. So let's go ahead and just write out the first couple of terms here. So for the first term, if I plug in 1, I'll get 1 over 1 plus 1 is 2. 1/2 is our first term. If I plug in n is 2, I'll get 2 over 2 and 1 is 3, so 2/3 is the second term. Plugging in 3, I'll get 3 over 4, and so on and so forth. Okay, now the sequence doesn't necessarily have to begin where n is 1, so as another example, I could say start things when n is 3. Okay, so if I plug in 3 here, that's going to generate the first term of this sequence. So I'd get -1 to the third power. That's just -1. And in the denominator, I have 3 squared is 9, minus 1 is 8. So -1/8 is the first term of this sequence. And then if I plug in 4, I'll get -1 to the fourth. That's +1. And downstairs, 4 squared is 16, minus 1 is 15. So 1/15 would be the second term, so on and so forth. All right, so now a little side note here. Notice I didn't write that superscript with the infinity. Okay, it's always going to be assumed for us that we'll work with infinite sequences, meaning there's an infinite number of terms in our sequence. We ultimately want to do calculus with these sequences, things like taking limits, and that's really only appropriate if you have an infinite number of terms, as we'll see. Okay, so I just want to make that note there. That's why, sometimes you'll see the infinity written in there just to be explicit. Sometimes you won't. All right, so now for the last example, we have a sub n is n times the cosine of pi n. Now here, right, there's no indication of where to start n. And if it's not indicated, then it's just assumed to start at n equals 1. And so let's go ahead and just write out the first couple of terms for this sequence. Now, if n is 1, I'll get 1 times the cosine of just pi, right? Pi times 1. Now, the cosine of pi is -1, and so I'll get 1 times -1 is -1. That's our first term. Now, if n is 2, I'll get 2 times the cosine of 2 pi. Cosine of 2 pi is 1, so 2 times 1 is +2. If n is 3, 3 times the cosine of 3 pi. Cosine of 3 pi is -1, so that would just be -3. And then we get +4, then -5, so on and so forth. Okay, last comment here in this example. Notice that this term, the cosine of pi n, is just alternating the sign as we move from term to term, just like we saw in this example above here. And so really this thing is just simply equal to -1 raised to the n power. All right, now that's going to do it for this intro video. In the next video, we'll go ahead and make a few more definitions about sequences, and then we will see how to visualize the terms of a sequence graphically. All right, I'll see you there. Thanks.